In this video, we're going to discuss sampling techniques, the three different types that are mentioned in the textbook: simple random sample, stratified random sample, cluster sampling, and then there's a fourth one, systematic sampling. Not in the textbook, it's just a simple fourth one to add on though. First, simple random sample. A simple random sample of size n is chosen in such a way that every group of n individuals in the population has an equal chance to be selected. So anybody that gets chosen here, it's of equal probability. Why do a random sample? What's the point of doing it? The reason is that humans are incapable of being random. If you attempt to try to be random, you eventually come back to some kind of systemic way of thinking, and therefore it's not random at all. So since we're incapable of being random or making random choices, we outsource those to technology. And technology could be a calculator, could be a computer, it could be a giant book of random numbers. That's a piece of technology. They used to use it back in the old days where you'd open up a textbook and it would be hundreds of pages of just random integer sequences. So you just pick random numbers, pick random page, and then that's another way of doing a random numbers collection. But we are incapable of doing that, so we must do a random sample regardless. We're going to talk about how to actually use the TI-84, and then we're going to talk about how to use Table D from the back of the textbook to find random numbers. So on your TI family calculator, if you go to the math menu under alpha, there is a probability menu right here, PRB, and the random integer, rand int, that's what you're going to choose for your random integer. Here's the actual directions. I'm going to write them out. Math PRB, choose random integer, and then in that set of parentheses you're going to write three things: your smallest number, largest number, and the last number is optional. You can leave it blank and not do anything, or you can choose. It's how many numbers you actually want. So how many numbers you want. If you just want one, you don't have to put anything in the third spot. You can just press enter after these first two. So it says, assume that every student in our high school is assigned a 3-digit number. The numbers are from 001 to 800. Create a method for finding a sample of 10 students using the calculator. So you're simply going to use random integer, and you're going to make sure in the parentheses you put 001, 88 or 800. This is going to be your smallest number they can choose from, the largest number you can choose from, and we want 10 numbers for 10 students. That goes there. So let's try that out. So random integer 001, 800 is the largest, and we want 10 of those. And it gives us a list of 10 numbers that are 3-digit between 1 and 800. So you can actually highlight or actually scroll across, you can see all 10 of those. And if you want 10 more numbers, do it again, and you get 10 different numbers on top of that, and you can keep doing that, so on and so forth. Now, Table D is a great resource in the back of the book. It's right after Table A, B, and C. Not surprisingly, it looks like this. And here's what it is. This line, this column, this is not part of the table. This is just referencing what line that we're at. This, all of these columns here and going all the way down the paper, this is Table D, all the random digits. So when you're using random digits, you're not going to use the 3 digits in this line column. It's just right here in these columns. So for example, if I want to do random 3-digit numbers from 001 to 800, you have to create a plan to use this table. You could just randomly spot 3-digit numbers wherever you want, but it's best to just go ahead and create a plan for it. So let's do this. I'm going to say start with row or line 101. That's the first step. You're going to look at every 3-digit sequence. And you have two options here. If it is between 001 and 800, we're going to use it. If it isn't in between 001 and 800, or it's a repeat, we don't use it. You're going to repeat this until you have 10 numbers. So if we look at table A, we're going to start with line, sorry, not table A, table D. Start with line 101. I'll try and zoom in here. Okay. So every 3 digits we're going to look at if it's in between 001 and 800. So I'm going to read them out loud and then keep track of them on my notes paper. So line 101, first 3 digits, 192. 192 does fall within that range of 001 to 800. So I'm going to write that down. 192 is my first random digit. Next, 239, that counts as well. 503, 405, that also works. 756, 287, 139, 640. We're at 8 digits so far, or 8 numbers so far. 912. So here would be an example of 912. That falls outside the range of 001 to 800, so we're going to skip that one. 531. That one does work. 425. We have gathered 10 numbers. Let's double check to make sure we didn't use any repeats here, and we don't have them. So that would just be one type of example out of literally an infinite number of ways of actually finding random digits. And we come up with an actual number list that looks like that. 192, 239, 503, 405, 756, 287, 139, 640, 531, 425. It's important to know that we had 3-digit numbers. We had to write it like, for single digits or double digits, we had to put that 0 in front because when we're doing random integers on a table, it's got to be the same width. So even though, 1, we don't write as 001 usually, but in terms of the random integer table in table D, you need to have 3 digits. The same for all 3. All right, so that is a simple random sample. It is the most popular method because of the inability of humans to actually be random or make random choices. The next type of sample is a stratified random sample, and we use the word stratified because we're finding strata. So to get a stratified random sample, start by classifying the population into groups of similar individuals. So find groups within the population that are similar and make those strata. We're going to call those strata. Then we're going to choose a separate simple random sample in each stratum and combine these simple random samples to form the sample. So you split the population into strata, then you do a simple random sample of each strata, and then you take all the samples, combine them together. Why do we use this method? So there's a couple reasons. Number one, if you have subgroups, you're going to want to know what they're thinking about, or if they're humans, or if you have very similar aspects of that population, you want a detailed look at those. You're going to want to make sure we hit every single subgroup. So if you have subgroups of the population that are very similar, you don't want to miss out on representing those groups. And it's just a way to be fair as best you can. This is appropriate when you have distinct groups within a population that you want to represent. If you don't have any distinct groups, this is probably not something you should be worrying about. But if you do have distinct groups, it's something to keep in mind to do. For example, create strata for the population of high school students. You can do a bunch of different ways. An easy way to split this up would be into 4 groups: freshmen, sophomores, juniors, and seniors. If you wanted to prevent a senior or junior heavy sample and you wanted to make sure you got a little bit of each, you would simply just make these each strata and do a simple random sample of each group or stratum, and then combine them afterwards. That is a stratified random sample. We don't use SRS for this one. When we say SRS, we mean simple random sample. I know this one's also SRS, but the simple random sample is going to be the SRS abbreviation. Stratified random sample will always write out as a stratified random sample. All right, the third sample is very similar in a way to, or students think that it's similar to a way in a stratified random sample. They get confused with cluster and stratified frequently. So we're going to make sure that we get those ironed out individually because they are very different. So to get a cluster sample, start by classifying the population into groups of individuals that are located near each other called clusters. Then choose an SRS of the clusters. All individuals of chosen clusters are included in the sample. So here you're going to make the entire population into clusters, and then you're going to choose an SRS of the clusters. So if you have 100 people and you make 10 clusters, you would only choose maybe 2 or 3 or 4 of the clusters. You're not going to choose all the clusters. Why use this method? If you have clusters of subjects that represent an entire population, it is easier and cheaper to use. A few clusters represent the entire population. So if you have a way to avoid using more time or more money, this could be an opportunity. If you have clusters that are representative of the population and you don't have to do every single person in the population, it might be easier just to do a certain amount of clusters rather than try to do a simple random sample of strata or the entire population. So let's write down this reason why. If you have clusters of subjects that represent an entire population, it is easier and cheaper to use a few clusters. to represent the population. And it might be geographical. The clusters might be separated by geography, and maybe you could choose just 2 or 3 in a random way, and you don't have to travel that far to do the sample. So just a quick alert here again. Strata and clusters seem to be very similar. You might be thinking, well, what's the big difference here? Strata, each strata contains similar individuals. So every single actually it should be stratum. Each stratum contains similar individuals. So like I said, freshmen, sophomore, juniors, and seniors. Clusters are different. So each cluster looks like the population on a smaller scale. So for the stratum that we did, in the example of seniors, juniors, sophomores, freshmen, for a cluster example for high schoolers, you have to pick something that would have a good representation of the actual population as a whole. So you need something with seniors, juniors, sophomores, and freshmen. A lunch. Because we have 2 lunches and not the entire population, if you picked A or B lunch in a random way, that could be an example of choosing a cluster out of 2 that would represent the population on a smaller scale. So there's an example there. You could have other examples with maybe sports or clubs. As long as the cluster looks similar to the population as a whole. All right, so this example we're going to do is going to illustrate how to do the 3 different types of sampling that we mentioned with corn crops. So a farmer has a rectangular shape of corn crops right next to a river. The land inside the rectangle slopes downward towards the river. She's planted 30 rows parallel to the river, 40 crops of corn. She will need to sample some of her crops to test chemical content, and she can't afford to destroy all of her crops. Create a sampling technique for each of the previous 3 mentioned: simple random sample, stratified, and cluster. So I'm just going to draw a picture for you and just kind of number it. So 30 rows. So planted 30 rows parallel to the river. That's 1, 2, 3. We'll do ... 28, 29, 30. And then next to that, we're going to have a river. So we have 30 rows here, and there are 40 crops in each. So 1, 2, 3, ... and we'll do 39, 40 down here. So we have one giant rectangle here. Okay. So the river runs parallel to the rows, so we'll put that here. And remember that the land slopes downward towards the river. So I'm going to draw a giant arrow in the middle here. So slopes downward, going in this direction. So we're going to do the 3 different types of sampling techniques to actually find a good sample from this 30 by 40 rectangle of crops. So a simple random sample. What we could do is the number of the crops, 001 to 100 and 0001 to 1200. And that way we have 1200 crops numbered. Then we're going to either use the calculator or Table D to choose a random sample size of 40 crops. So we just chose 40 crops. Whatever, it wasn't mentioned in the problem how many she actually want the simple sample size to be, but since she has 1,200, 40 crops is not that much of a high of a percentage of the overall total. Stratified random sample. So remember, for stratified random sample, we need groups of similar things. So what we can do here is break this crop field up into groups that are similar. This should be a little bit easier because if you have a river here, as you go inward, the crops get further and further away from the river. So maybe water content changes on its way down towards the river, and this land slopes downward. So groups that are similar to each other would be the rows going in this direction, parallel to the river. This row here would be the furthest away. All these crops are furthest away from the river. They're all pretty similar. They're all up on high on the hill, on the slope. These crops down here are right next to the river. They're at the end of the hill. They're all very similar to each other. So our strata are going to be our rows that are parallel to the river because they're in a similar situation. So you're going to make 30 strata. That's because the rows are similar. And do a simplified random sample of each and combine results after. Now we didn't go into detail what the simplified random sample would be for this one, but it really could be anything. But you need to do a simplified random sample for each one of the same size. You combine them afterwards, and that is your stratified random sample. Now, let's contrast stratify with our next one, our cluster sample. So now for our clusters, we need to find groups of crops that represent the entire population. Well, in order to do that, we need to understand what our population looks like. We have a rectangular crop piece of land right next to a river. It slopes downwards. So the entire rectangular crop slopes downwards like this. So we need to split these up into groups where it represents the sloping downwards and getting closer to the river. So if you go in this direction horizontally towards the river, one of these clusters will represent the entire population because they're all repeated 40 times. So every one of these columns essentially, would be a cluster. So we're going to make 40 clusters because they represent the entire population. And do a simplified random sample of the clusters to choose 1 to 3 clusters. So, simplified random sample, it's just randomly from all 1,200. Stratified, you find groups that are similar to each other. In that case, it was rows. This row is all the furthest crops away from the river. This strata or row is the closest crops to the river. Clusters, you find clusters by finding groups that are representative of the entire population, or it's like a mini population, and that was going in this direction. You had crops that were furthest away from the river, you had crops that were closer to the river, and that everything in between, that represents the entire population of crops here, and that's what made up our clusters. You do a simplified random sample of the entire set of clusters, which there are 40. We, in this case, chose 1 to 3, and that'll be your sample. The last type is not mentioned in the book. It's a very simple counting sampling method. It's called systematic sampling. It's every kth member of a population is chosen for a sample, with a value of k being approximately big N divided by little n. So that's going to be population divided by sample size. So redo the previous example featuring the corn crops with this technique. So total was 1,200, that's big N. Little n, we're just going to choose 20. This can be anything. So it can be any size sample you want. And when you do this, you get 60. So this means you're going to choose a random starting point. And then choose every 60th crop. 60th becoming from that number right there. It'd be very similar to like people standing in line for the newest iPhone and counting every 10th person and sampling them. It's essentially what it is. You're just counting every few number of people. It's a simple method. It does have a lot of issues with it though, because there's no way of being, the way you're being random is by simply choosing a number and not trying to represent the population. So there's a lot of weakness to it. It's not really covered in the textbook at all, but it is out there. It's just a way of another way of sampling it. So sampling techniques, there are 4 total, 3 that are really important here. Simple random samples, your most easy or the most popular one. We use SRS to abbreviate it. Stratified random sample. Remember that strata are groups that are very similar to each other. That would be your seniors, your juniors, your sophomores, your freshmen of your high schoolers. So you find all those groups, you do a SRS of each group, and then you combine them afterwards. A cluster sample, it's different than a stratified random sample. A cluster sample is you break the population into clusters of individuals that are representative of the entire population, so like mini populations. And then you do a simple random sample of all the clusters, and you choose 1, 2, 3, 4, 5 clusters out of the total, whatever the number may be. And the systematic sampling we just went over right here.